I'm Dr. Howard Zucker, the doc in Docology. It's soon to be that time of year again, mosquito season, when those pesky little biters somehow manage to crash every party, every picnic, and otherwise every perfect summer day. But here's a fact that might surprise you. Of the more than 100 billion people who have ever lived on this planet, nearly half of them have died from diseases transmitted by mosquitoes. And they're still a threat today. These tiny suckers literally have shaped history. They have toppled empires. They have sickened everyone from peasants to presidents to popes. And our guest today is someone who took that surprising fact and turned it into a fascinating, compelling book. Professor Timothy Winegard of Colorado Mesa University is the author of the New York Times bestseller, The Mosquito, A Human History of Our Deadliest Predator. He's a military historian, a former officer in both the Canadian and British Armed Forces, and this is important, a self-proclaimed Jedi and major Star Wars fan. So, Professor Winegard, let's start here. What on earth inspired you to write a book about mosquitoes? Dinosaurs, sure. And great white sharks, absolutely. But why mosquitoes?
Well, first of all, thank you for having me on your show. It's my pleasure. There's a convoluted story that I'll narrow down for time's sake. Is The Mosquito was my fifth book. I had written four others about military history, indigenous peoples, which are my two historical passions. And I wanted to write what I call airport books. It's the books you only see in the shops at the airport, like Guns, Germs, and Steel, Sapiens, those type of Cod or Salt by Mark Kurlansky. And so my dad, who's an emergency physician back home in Canada, he said, well, dengue is making a comeback and malaria is a huge killer. You should write a book on malaria. And half jokingly and almost mocking him, I said, sure, Dad, I'll write a book on mosquitoes. And I actually started researching and very quickly went down the rabbit hole of how mosquito-borne pathogens have shaped our humanity and our history more so than any other external factor, and realized very quickly that this was the topic, and it was a topic that had never really been written about before. So the vacuum was there, and again, it was beyond my wildest dreams, the media attention that it got. I'm a small town boy from Canada who wanted to be a hockey player. But anyway, so that's the basics of how I came around to the topic of mosquitoes and how their pathogens, they vector, shape humanity.
Amazing. And it's not just in airports, it's in bookstores, it's everywhere. So, right. So you thought it would end up just in an airport. I know those little shops, but when I found the book, it was in a major bookstore and as on the bestseller list. Unbelievable. So we have 110 trillion of them out there, and somehow they always find us at the worst time, right? We're at a barbecue. So, but what makes them so good at finding us? I mean, what is it about these mosquitoes that they know where you are and they grab you right at the right moment or the wrong moment?
Well, first of all, there's roughly 3,700 mosquito species on the planet, and very few of them, actually, a few hundred, are capable of vectoring these pathogens. So it's not all mosquitoes. However, all female mosquitoes bite. It's only female mosquitoes that bite, and they simply need the blood of humans and a zoological Noah's Ark of other animals. They bite all animals to grow and mature their eggs. So don't blame the mosquito. Untethered from a pathogen, the mosquito itself is harmless. They're just trying to be good mothers. Collect some blood, grow, mature their eggs, and do what they're programmed to do, which is reproduce, like all species on this planet. So that's the reason why they are so good at it, is it's literally tied to their survival. If she doesn't get her blood meal, she can't reproduce those eggs, and their species would die. So that's why they're good at it. Evolutionary survival of the fittest. They've adapted some. Again, if the mosquito didn't delve out so much death, suffering, and destruction, we would marvel at how sophisticated this animal actually is. But to your point, there's a lot of mythology out there about who they bite or don't bite. 85% of why you are more attractive or less attractive to the mosquitoes is hardwired into your DNA. So unless you CRISPR yourself, you can't get rid of these traits. And that is how much bacteria you have on your skin, how much CO2 you emit, your natural body temperature, your stink and smell. But it has nothing to do with skin color, hair color, eye color, men or women. That's all mythology. How much garlic you eat. Obviously, they're not vampires. And pregnant women, their body temperature is slightly raised, so they do get a bit more, which when we look at malaria, 90% of malaria deaths are children under the age of 5 or pregnant women. So that's so they hunt essentially by infrared sight. So think of like night vision goggles almost, heat signatures, and smelling, if you will, carbon dioxide, which we emit through our breath and through just naturally. So that's how they hunt. And so again, it depends on your blood type as well. Blood type O is their vintage of choice. A is the least preferred, and B is somewhere in the middle. So there's a lot of different factors, but again, 85% is hardwired into your genetics.
So this whole thing about redheads are more likely to attract mosquitoes is just is a myth.
It is, and they don't prefer blondes, although Marilyn Monroe might not agree.
And then they leave a little bit of their saliva behind, and that probably is what causes the whole reaction that makes you itchy and swelling and redness, the whole histamine response that we get. I get it.
Right.
But they've been around a long time, right? These mosquitoes have been around hundreds of millions of years, even when the dinosaurs roamed the earth, right? And they're getting tougher. Are they getting more resistant to all of these insecticides that we put out there or that we manufacture? Are they smart enough to figure out how to change for that?
Yeah, so they're, again, an evolutionary marvel, and they evolve very quickly. They've been around in the modern form roughly since the late Jurassic period, and the dates differ, but somewhere between kind of 130 and 190 million years ago, what we would view as modern mosquitoes, and then have evolved very quickly to circumvent our frontline weapons of mass destruction to continue to survive and breed and again, do what they're programmed to do, which is to survive and procreate. So certainly dinosaurs, not quite the Jurassic Park story, but dinosaurs were victims of mosquito-borne pathogens and pathogens from other insects that are vectored to the dinosaurs. There was extinctions of certain species, or when the meteor hit 65 million years ago, some dinosaur species are either extinct or in the process of becoming extinct because of insect-borne pathogens, including mosquito-borne pathogens.
Isn't that amazing? A little mosquito versus an enormous dinosaur out there. And with Jurassic Park and all of that, right, there's some artistic license there, right, with Steven Spielberg, right? Because he said that was the mosquito that had the dinosaur DNA in it. But is that really true, or was that the wrong mosquito?
So there are mosquitoes that are encased in amber found in Canada. The oldest ones are found in Canada and Burma and Myanmar, and they are somewhere from 105 to kind of 80 million years ago. And they do contain vestiges of dinosaur DNA. So part of Jurassic Park is right. But the mosquito they use that's encased in the amber in the movie is the largest mosquito species on the planet. And it's beautiful and big and has some striping. However, the one in the movie is male, so it wouldn't bite. And two, that is one of the very few mosquito species on the planet that neither male or females actually bite. So it's wrong on many accounts. And so, yes, there was some poetic or artistic license in choosing that mosquito, which scientifically is not so sound, but
makes for a good movie. That's what's
important. Because it's
mosquito. So you mentioned dengue, but malaria, Zika, yellow fever, there are some deadly diseases out there that mosquitoes are able to transmit. Can they transmit more than one disease, or do they just pick one disease at a time?
So the Anopheline species of mosquitoes, that is specifically malaria. But the other, which is its own, so if we think of the pathogens that mosquitoes transmit, we can roughly divide them up into three. There is the worms, which is filarial worms or filariasis, which is the engorgement, blocking of the lymphatic system, the engorgement of limbs, hands, genitals, like scrotums the size of beach balls. Literally, it's horrific, which can be cured very easily with a 2-cent medication. And so, but unfortunately, hundreds of thousands of people still, millions of people still contract filariasis in lower socioeconomic developed countries. So that's the worm category. The viruses class is the biggest category, with yellow fever being the paramount killer. There is a vaccine for that, thankfully, that was developed by a South African American in the interwar years. And then we have dengue, Zika, West Nile, chikungunya, all these Venezuelan encephalitis, Eastern equine encephalitis. I can go on and on and on. There's hundreds and hundreds and hundreds. Jamestown canyon disease, snowshoe hare, hundreds of viruses. And then malaria is a protozoan parasite, which is in its own category, and it is highly sophisticated from an evolutionary standpoint, and is the paramount killer of humanity. So the anopheline mosquitoes is specifically malaria, but other mosquitoes, the Culex mosquito or the Aedes aegypti, which is essentially enemy number one for the virus category, and worms, the filarial worms. So they can transmit multiple of the viruses. Again, there's very select species that are kind of the ace, king, and queen of spades on our deck of cards that we're going after, like they handed out to us in the military. So Aedes aegypti is essentially enemy number one for the virus class.
So I actually have as a gift from CDC, which is hard to see, but I have a little mosquito in there, which is the one that you mentioned that carry malaria, and that's on a little pin there. But they're small, but they are pretty deadly. I got this from the CDC, and I said, I should just save this. Cool. One day my kid will have a show and tell, and this will be perfect. Little did I think that it'd be show and tell for the podcast. But mosquitoes that cause malaria, one big issue. But right now, like 1.5 billion people are infected by mosquitoes every year, and about half the planet is at risk. So I find it's really one of the most dangerous animals, if you want to call it animal, on Earth. But you've written an incredible book about history, and I thought maybe you could share a little bit about mosquitoes' role in history, whether it's the war for independence here in America, the Civil War, or Athens, Sparta, or Alexander the Great, or even whether mosquitoes took down Rome. So I thought because you've touched on all of this, I thought maybe you could share a little bit with us about what its role has been in history, particularly some of these big issues that have happened.
Yeah, so we like to assign or ascribe great historical events to our wonderful national or international men and women, our heroes. And often the case is it's external factors that are the game changers for these historical events, not so much what humans do at all. But our hubris gets the better of us, and we like to assign all the fame to our own species when, in fact, that's usually not the case. It could be horses, it could be rats, it could be climate change. There's so many external factors that influence historical events, and we kind of overlook them to our own detriment in many cases, specifically with infectious disease, whether that's Black Death and plague, or mosquitoes, or the influenza for that matter. So there's so many examples where looking at the primary sources and kind of going back and looking throughout history where we see the mark of specifically malaria and yellow fever in shaping our histories and being the pivotal or cataclysmic player in certain events where it's not human agency whatsoever. The outcome of these game-changing events were driven by mosquito-borne pathogens. So you named a whole host of them, which I talk about in the book. Another one that I didn't believe at first, and I did more research just to make sure I had it right, was when Scotland surrenders its sovereignty to England in the creation of Great Britain in the early 1700s is actually caused by Scottish debt and Scottish bankruptcy, because they poured all their money into a colonial adventure in Panama, trying to create a Panama Canal at Darien. And these colonists in this enterprise, well, multiple enterprises actually, are cut to pieces by mosquito-borne pathogens, specifically yellow fever, in the wilds of Panama. And so England says to Scotland, hey, we'll agree to pay off your debt or eat the debt if you agree to surrender your sovereignty and become part of England. And they do. So the independence of Scotland was actually sold to England because of mosquitoes in the wilds of Panama and a failed colonial expedition called the Darien Expedition, which again is fascinating when you think of the geopolitical ramifications of that over the next 300 years. It's fascinating to think about history through the lens of mosquito-borne pathogens. So for the American audience, the American Revolution, Cornwallis's surrender at Yorktown actually has nothing to do with what the Americans are doing or the French allies with Rochambeau and General Lafayette. Actually, it's the mosquito, the female Anopheles mosquito, is a founding mother of the United States. Long story short is up until 1780, the battles had been primarily fought in the north, in the northern colonies, away from the mosquito belts or the endemic malaria in the American colonies, because the American colonies were awash with malaria. And in the final campaign, General Clinton dumps Cornwallis in the south with 9,000 troops. And the soldiers that Cornwallis is in command of are away from the malarial belt of England. They come from northern England and Scotland, away from the Fenlands, which is the kind of malarial epicenter in England. So when we look at malaria, there's a term that the British use called being seasoned. Essentially, the more you suffer from malaria, the less you suffer. Now, I don't suggest this as an inoculation strategy, but with repeat infection, you have a lesser chance of dying and the symptoms become less severe. So the American troops in the South under predominantly General Greene had been seasoned to colonial malaria, whereas these British soldiers had not. So they're dumped into the malarial zones of the Carolinas in 1817, 80, 81. And immediately you see Cornwallis's route march. He's zigzagging across the Carolinas, essentially asking what he believes are loyalists in the South, like, where are we free from the ague, as the British called it? And they go over here. And then they get sick again, go over here. And then when he's ordered to Yorktown, he actually says, please don't make me hole up in Yorktown. It's in between the James and York rivers, and it's rice fields, so it's swamp. In August, which is the perfect mosquito breeding season and malaria season. And his superior, General Clinton, orders him there because he's convinced Washington is going to attack New York, which he doesn't. So he puts them in Yorktown, and immediately the Brits are cut to pieces by malaria, and the Americans and French lay siege to Yorktown from August till October, which is the worst malarial season in Virginia. So prime time for the Anopheles mosquito to do her work. And Cornwallis surrenders. And when he surrenders, he has about 35% of soldiers who can even stand up to post. The others are sick, dead, or dying of malaria and not of combat whatsoever. And he writes about this in his diaries. He writes about this in his letters to General Clinton. So in effect, it's the Anopheles mosquito and malaria that secure Cornwallis's surrender at Yorktown, and we should have the protruding face of an Anopheles mosquito on Mount Rushmore tucked between George and TJ, looking admiringly at her. Because say there's founding fathers in the U.S., which there certainly is, but the Anopheles female mosquito, because females are the only ones that bite, is a founding or the founding mother of the United States.
Oh, well, on that is amazing. That is just an amazing story. And I have a dear friend from Scotland, so I'm going to ask her about that issue, whether she knows the history there on that. So that's the American Revolution issue, and obviously Scotland on a different issue. But you mentioned about the Panama Canal, and you just mentioned about Teddy Roosevelt as well. A lot of what malaria did basically was sort of destructive in some nature, but the Panama Canal was a constructive issue, right? Construction of this canal was great, and many people did try. David McCullough, you're a colleague author of yours, wrote The Path Between Two Seas. But can you talk a little bit about how other countries were unable to do, as you just touched upon, but how the United States was able to build that Panama Canal because of what we were able to do on the public health front to tackle not only the issues of malaria, but also particularly yellow fever there.
So the Spanish, obviously the Spanish are playing solitaire of colonization in the Western Hemisphere for about 100 years before the French and British really get involved. In the kind of late 1500s, early 1600s is when we see kind of England and France get involved. And so almost immediately upon colonization, the Spanish realized that the isthmus for trade, it would benefit if you could have essentially a trading path, not a canal, but a trading route. It would have been donkeys and horses that were. So on the southern side, all the riches coming out of what would be Peru would come up to Panama and be shipped across a essentially cart path to the northern side and then shipped to Spain. So they tried this, and the estimates are that the Spanish lost somewhere between 40,000 and 60,000 people, including indigenous laborers, trying to build this path across the Isthmus of Panama, and failed miserably because of yellow fever. Yellow fever was the paramount killer in Panama, as I mentioned earlier, with the Darien colonization with Scotland in the late 1600s, early 1700s. And then obviously the French tried, the Scottish tried, as mentioned with the Darien expedition or colony. And then it's kind of a twofold story, is that American imperialism, Cuba, actually leads to the medical breakthroughs that are used to develop the Panama Canal. So Walter Reed is in the U.S. Army, and he's assigned to Panama during the Spanish-American War, and he piggybacks on the work of a man named Carlos Finley, who's Cuban, who actually deserves all the credit, not so much Walter Reed. And Walter Reed actually admits this. He's embarrassed that he gets credit for uncovering the connection between the mosquito and yellow fever. And he says Carlos Finley deserves all the credit, but there's a degree of kind of American exceptionalism in here that they want to give him the credit. And he's actually very ashamed that the credit doesn't go to Carlos Finley, whom he mentions all the time, to try to prop up his experiments and his research, which really uncovered that connection in Cuba. So William Gorgas was again in Cuba trying to get rid of yellow fever with the knowledge from Finley and Walter Reed. And he's transferred to Panama to get rid of yellow fever, knowing that it's caused by mosquitoes. And he puts in a bunch of, prophylaxis, if you will, by cutting back the forest, spraying for mosquitoes with insecticide, with this really pyrethrum from chrysanthemums at this time, and literally cuts yellow fever out of the equation. And so because of the research and unmasking the mosquito as the culprit of yellow fever, and then the prevention thereof in Panama, the Americans are able to blast a canal through there that's opened in 1914 for global trade and spinning revenue, money spinning revenue as well. So that's the brief story of the Panama Canal. And as Teddy Roosevelt said when he found that out, his only orders were make the dirt fly, in typical Teddy fashion.
It's a marvel of engineering, but in actual fact, it's a success in public health, because without that, the engineering never would have happened. So we were able to basically change history in many ways as a result.
Yeah, because of global trade. Obviously, this is right at the beginning of the First World War when the Panama Canal opens, and it's part of the reason why America becomes an economic superpower as well, because most of the industry at this time is still in the Northeast. And so you'd either have to ship it by train all the way across to the ports in California, or sail it around South America, which just didn't happen because it's not economically really feasible or viable. So now you can cut across, and it opens trade even more so with Asia, which is a game changer for global economics, but certainly for American industry, which at this time is producing 40% of the world's manufactured goods, which is, that's insane when you think about that economic, monopoly of global production.
Humans, it is amazing what we've been able to do, but nature does its job as well. And humans have evolved with mosquitoes. So we do have some diseases which are serious and deadly in many ways, like sickle cell disease and thalassemia, which are blood diseases. But the interesting thing is that they evolved with time, and they protect you against malaria in some ways. So that maybe you want to talk a little bit about that, about how sort of nature has worked to protect some people from getting some of these deadly diseases, but ending up with a serious disease anyway.
Yeah, so the homeland of obviously Homo sapiens and mosquitoes and their pathogens, specifically malaria in this case, is Africa. So our hominid ancestors had malaria. Almost every animal on the planet has malaria. I mean, whether it's reptiles, amphibians, birds, the great apes all have their own malarias. Humans have 5 types of malaria, but so when we look at our hominid ancestors in Africa, they had malaria. Lucy would have had malaria, or her offspring. So we've evolved. We've had kind of a symbiotic relationship with malaria and mosquitoes throughout our evolution. So when we look, yellow fever is a virus. So if you contract yellow fever and survive, you're immune to it. And part of this, which we may have time to get into or not, is this also leads to African chattel slavery, is because they've developed immunity to yellow fever or have safeguards against malaria because of their own genetics. So whereas indentured European servants or indigenous peoples in the Americas are dying off in droves on these colonial hotbed plantations in the southern colonies or the Caribbean, Africans seem to have better survival rates because of this seasoning to malaria and yellow fever in Africa. So it's a dark side of mosquito-borne pathogens, is that it's one factor, not the sole factor, obviously, but one factor in African chattel slavery, which is obviously one of the darkest episodes in modern history, if not all of human history. So we develop very hasty responses, specifically when we look at sickle cell. It's a very hasty response because sickle cell disease, it allows you to withstand malaria. So you live just long enough, kind of your early to mid 20s, to procreate and pass on sickle cell so your children can survive malaria just long enough to carry on our own species. So when we think of natural selection, obviously there's no preordained, it's luck and mostly dead ends in death, and there's no design to natural selection. It's a very hasty response because it's both a killer and a savior at the same time. It saves you from dying of malaria as a child just long enough to procreate to pass on sickle cell, but then you die in your early 20s. So it's a very imperfect response, or hasty natural selective response to what must have been, genocidal or cataclysmic rates of malaria in sub-Saharan Africa, 10,000 to 20,000 years ago.
So very interesting. And there is some amazing scientific efforts being made to sort of tackle sickle cell disease and trying to eliminate through some of the genetic engineering. But even with the genetic engineering for tracking sickle cell disease, there's also genetic engineering being done now to try to get rid of the mosquitoes that carry the malaria infection, right? And so this is some work that's being done, right, with funded by the Gates Foundation. Maybe you could talk a little bit about what they're doing to try to remove malaria-carrying mosquitoes in the world.
So again, I was in the military for 9 years in the Canadian and British armies, and I equate our war with mosquitoes to the military. Is when you go into combat, you don't go into combat with one weapon system, meaning you just don't use air power, you just don't use infantry, you just don't use artillery. It's a combined arms kind of front that you go into combat with multiple weapon systems for specific targets. So there's two kind of things we look at. Is one is the pathogen itself, and the other one is the delivery system, which is the mosquito or the specific mosquito species, whether it's the Anopheles mosquito or, in the case of yellow fever and those viruses, predominantly Aedes aegypti. So we can target the pathogen with vaccines like the yellow fever vaccine, or trying to develop a malaria vaccine, not in the traditional sense because it's not a virus, but the RTSS that came out of Oxford, the most recent vaccine, is showing some promise. So we can target the pathogen, and then we can also target the mosquito species themselves. So, for example, Wolbachia bacteria is now being used to infect mosquitoes that transmit dengue with no harm to them. All it does is it prevents them from actually transmitting the dengue virus to humans. So we also use, or experimenting with, because in the wild, it's worked fairly well in controlled experiments in the lab, but once we release it into the wild, it hasn't had as much success, which is CRISPR or gene editing, something called a gene drive. So we CRISPR mosquitoes in a lab. So when they're released, when they procreate, they either only procreate male offspring, thereby bringing down that mosquito species, or they procreate fertile offspring, thereby bringing down that mosquito species. So again, I need to stress that nobody is promoting the eradication of all mosquito species on the planet. Not at all. They're targeting very select species. Mosquitoes are ecologically important, and they play a role in the homeostasis of ecosystems. And given that you brought up that I'm a self-proclaimed Jedi, there's a balance to the Force. And if you interrupt the balance to the Force, bad things happen, like the rise of the Sith. So we don't want to eliminate mosquitoes. They're important food sources for bats, birds, topwater fish feeders. They're pollinators. They're not quite to the extent of bees, but females bite to get blood to grow and mature their eggs, but males and females also drink pollen. That's their food source. So they are pollinators of numerous plants. Specifically, if we removed mosquitoes, certain orchid species would go extinct because they're only pollinated by mosquitoes. So no one is suggesting the eradication of all mosquitoes across the planet. And so it's targeting very select species. So through gene drive or through, spraying or whatever else, Wolbachia doesn't hurt the mosquito, but specifically dengue. So those are some of the, I guess, weapons we're trying to use against mosquitoes. But to your earlier point, when we look at DDT, which was a miraculous mosquito killer, it is the reason there's no more malaria until recently in the United States, because there's domestic malaria now, and we've seen it in Florida, which is very scary last year. But in 1951, the U.S. was declared malaria-free. And Canada shortly before that, again, there was malaria in Canada and yellow fever outbreaks in Canada as well. So it's because of DDT. But why we banned DDT is not so much because of its environmental degradation. It's more because it doesn't work anymore on mosquitoes, because farmers carpeted the planet with DDT beginning in the 1950s. And so Joni Mitchell's right, fellow Canadian, when she says, farmers, put away your DDT, leave me spots on my apples. It was the industrial use of DDT for agriculture that allowed the mosquito to just take showers in it and bathe instead of being killed by it. It took somewhere between 7 and 10 years for the mosquito species to become immune to DDT. The average is about 6 or 7. So by 1972, when it's banned in the US, it's simply because it doesn't work anymore. Not anything Rachel Carson wrote or Joni Mitchell sang, unfortunately.
They're both stars in their own right, and made major changes in what they did, both music, but also the whole environmental movement. Staying on that concept about the ecosystem and everything being in balance, are we disrupting that by all the climate change issues, right? Because we are starting to see mosquitoes, particularly types of mosquito that usually don't get as far north. Is there something that we should be concerned about? And how do we make sure it doesn't become a different problem?
Yeah, so there's absolutely climate change is affecting the distribution of mosquitoes, and then obviously mosquito-borne pathogens that are carried with them. So again, Aedes aegypti is an African mosquito, and it came over to the Western Hemisphere as a stowaway on board the slave ships and trade ships, and found a very sanguine home in what was originally the Caribbean, Central South America, and the southern colonies. But because of global warming, we're seeing the Aedes aegypti. Not only it's in southern Ontario, where I come from in Canada, they're finding the Aedes aegypti in the Great Lakes region now of Canada, which is very scary, and also higher altitudes. So it's pushing the northern limit line into Canada and parts of Europe, but it's also being able to survive at higher altitudes because of climate change. And then you're seeing then dengue, chikungunya, yellow fever, Zika. All these viral pathogens come with this mosquito as it pushes north.
And so they go further north, but then winter ultimately will happen. And where do these mosquitoes go? I mean, what do they hibernate? What happens to
They
them?
hibernate, and yes, they hibernate. So The Arctic of this is some of the things that people are like, wow, I wouldn't have thought of that. The Arctic of Canada, because of how much water and the bogs up there, the Arctic of Canada, or the muskegs, the Arctic of Canada has the biggest mosquito populations on the planet for a very short period of time. Young caribou are bled to death by a bite rate of 9,000 per minute. I'm going to say this again. Mosquito swarms are so thick that they bleed young caribou to death at a bite rate of 9,000 per minute. So yes, they hibernate and then come back out, and they're obviously ferocious because they're starving, and they go after anything they can find. And so again, we think of kind of the tropics with mosquitoes, but they breed in water. So the muskegs or bogs in the Arctic form great breeding grounds. They hibernate, they come back out, and I've been up there during mosquito season, or in Newfoundland in Canada during this, and it's it's interesting. I'll leave it at that.
Oh my, 9,000 per minute. Isn't it? You think about that. Think about that for a moment. Wow.
Well, there's just so many mosquitoes on the animal at the same time, because I mean, if it's a caribou herd, it's the only thing for them to bite within hundreds of miles. So they just come after it. Yeah, it interrupts actually the seasonal migration patterns of caribou. It interrupts, or is a detriment to their reproductive patterns and herd sizes. There's actually people who study specifically caribou herds and mosquito bites, if you will.
These little buggers are quite amazing. You mentioned one of them just traveling, of course, maybe on an airplane. Another one, mosquitoes that a disease that spreads is West Nile virus, and we did not have. I mean, that it started back in many years ago in 1937, but that was over in Africa and Uganda. But we did not see that until 1999. In fact, that when it came over here, it was in New York. And there were some birds that were dying, and then some people got sick. And in fact, my brother's classmate from medical school, Dr. Deborah Asness, was the one who picked this up. She was the one who sort of said there is something wrong, why all these patients that she was following were getting this disease. And that set into motion the whole thing that ended up people figuring out about West Nile virus. So maybe a little bit, do you want to talk a little bit about West Nile virus? Because that's another serious issue. Even though most people, 90% of people who get it, don't have any symptoms, but those who do can get pretty sick, as she showed.
Right. So it's a benign cousin of yellow fever. So yellow fever kills roughly 25% of people who contract it, and it's a horrible death. The Spanish called it vomito negro, like black vomit. Basically, your innards rot and you vomit up your organs in the consistency and color of coffee grounds. And you start bleeding out of your nose and your ear. It's a horrible hemorrhagic fever. It's no good. So West Nile is I'm going to have some emphasis here. A very, 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 very benign cousin of yellow fever. So we think it's introduced to the Western Hemisphere in 1999 through New York via a bird that is a stowaway on board a plane that comes from Israel is the best guess. And again, that's not 100%, but that's kind of tracking it back. And then to your point, she noticed that birds were dying in the birds are a reservoir of disease. I should say that. I like birds, and unfortunately, bird populations are plummeting globally as well, which is a huge concern since the 1970s. But birds are a reservoir of disease. We think we actually got our malarias from birds as well, in a host of other diseases. But so they noticed that a lot of crows and ravens were dying in New York City and in the parks, and there's dead birds all over, and that the birds in the zoo were dying as well, the New York City Zoo, and that horses actually started to get sick as well and die. And so she connected the pieces between kind of all these happenings. And then by the time we identified West Nile, unfortunately, it was out of the stable and it was impossible to control by that time. And if you look at the chart of spread, it's every year it just pushes west. And even here where I'm in Colorado, we're in a West Nile hub out here. But the fortunate thing about West Nile is that it's very benign. As you mentioned, about 95% of people who contract West Nile show no symptoms. And then of the 5% that do, 99% of those will just feel a little off. Like you wouldn't go to the hospital even. You just, some days you just don't feel quite right. And then 1% of those would develop symptoms where they'd go to the hospital, but are still generally fine. And then 1% of those show true symptoms where they have the brain hemorrhage and brain swelling, and either can go into a coma and die or survive and have paralysis of the limbs. It's usually arms and hands. I have some colleagues here who contracted West Nile, and some of their fingers are still not quite fully operational because of the brain swelling and the repercussions of that. But it is an issue, and it certainly can be lethal, but it's far less lethal than yellow fever or even dengue, which is not only dengue. Death rates are kind of in the 4 or 5%, which is still terrible. But West Nile is it's very, very, very benign, but still can cause death and or certain paralysis in limbs. But it's widespread now across the Americas. It's all over Canada. It's all over the U.S., South Central America. Now, the one that's interesting to me is that, and I don't know enough about it, and maybe you do, is Zika is obviously another cousin of yellow fever, and it's transmitted by mosquitoes, but it's also sexually transmitted amongst humans as well, which I find interesting from an evolutionary standpoint, that this virus is kind of two pathways, mosquito bite, but also now as a sexually transmitted disease amongst our species, which is interesting.
It's fascinating about how nature does what it works to try to figure out how to survive and to keep pushing things forward. And some viruses we are the last host, right? So the virus infects us, and we can't. When a mosquito bites us, it doesn't then spread it to another person. There's so many things we could talk about, and I can go on for another hour. I'm sure you can too. What are 3 takeaways? What are 3 things you think we all should know regarding mosquitoes in general?
I guess the first one is I have a very grudging respect for these creatures, is because they've survived. Everybody's tried to kill them throughout their existence, and they are the true survivors on our planet. And that, unfortunately, they don't know they do this, and they're not doing this. It's the pathogen that's evolved to hitch a free ride that is the enemy, not the mosquitoes. So I have a very high respect for mosquitoes. The second one is don't give in to our arrogance and think that we're omnipotent on this planet and that we're the masters of our own domain, because we're not. And often our own hubris and arrogance leads to unintended consequences or not very good things. And I guess the third one would be mosquitoes are important to ecosystems and a balance to the force. And that I know our first reaction is to swat them and kill them, but they actually do serve a purpose in maintaining equilibrium to nature or ecosystems, or in my vernacular, a balance to the force.
Well, I'm wearing my butterfly tie because that also keeps a little balance to the system. So I have one last question before we go to our viewers. Given your knowledge of Star Wars, was it really Darth Vader who killed the Emperor in Star Wars Episode 6, Return of the Jedi? Or with those bloodshot eyes that he had, was the Emperor already sick with a mosquito-borne illness? As a Jedi warrior yourself, I thought you might have some inside knowledge on that one.
Well, he didn't get killed because he comes back.
Well,
remember, nobody's ever dead in Star Wars. That's the thing, is he keeps coming back somehow. He CRISPRs it. Actually, he uses CRISPR technology to clone himself.
But Yoda doesn't come back. I don't think Yoda comes back, right?
Just with Force glow. There's Yoda right here. Just with Force glow.
We should have maybe I'll do a whole podcast on Star Wars and how it applies to public health and medicine today. So we've reached that point in our show where we turn to our most important guests, which are our subscribers out there. So Kat's going to tee that up. Just a quick point. I always mention this, that The podcast is for informational purposes, so it's not in place of a doctor's visit, but it's important to listen to your doctor about any medical recommendations. But Kat, who do we have? And are you first online?
Always first at this point. Yes, I will actually be asking a question for one of the subscribers who cannot be on camera, but they were wondering, absent any other pathogens, can the mosquito saliva alone cause a serious reaction in a person who gets bitten?
No, so there's no blood exchange during a mosquito bite, and when HIV first kind of reared its ugly head in the 80s, at least came to the forefront, everyone was worried that I can get HIV from mosquito bite. Long story short, is there's mosquito, I'll call them needles. There's 6 needles. The first 2, think of a electric knife we use at Thanksgiving. They saw into the skin, and then 2 others go in and they act as retractors. They kind of hold the puncture site open. Then a 5th one goes in and pumps in saliva, which contains that anticoagulant, so the puncture site doesn't heal over. And an analgesic, it numbs the site a little bit so we don't detect her bite. And that's what gives you that itchy reaction, is because of the saliva. The 6th one goes in, that's a straw, and it pulls out blood. So the pathogens come through the saliva tube, not the blood tube. They're totally separate. So, I mean, some people have different reactions to mosquito bites. Again, I don't get bitten very much. My sister will get 100 bites if she's sitting beside me, and I'd get 1 probably. And I don't swell up very much at all. I'm lucky they just don't like me very much, which they should, because I made them famous. But so it just depends on those factors that I talked about at the beginning that are hardwired into your DNA. That's 85%. They do prefer people who are drinking over people who are not drinking alcohol, because it raises your body temperature a little bit when you drink. So they seek you out. Bright colors. So there's some other things, soaps and fragrances they like. So being stinky is a good thing, except for your feet. They love the bacteria on our feet, which is the same bacteria that's used to ripen cheeses. So wash your feet, but not the rest of your body.
So maybe that's why your
Don't
ankles,
shower.
usually you get a lot of mosquito bites by your ankles.
That's
right?
part of the reason, is the bacteria on our feet is like an aphrodisiac for these female mosquitoes.
I was actually going
Excellent.
to ask that question myself about the fragrance, because I thought it was a myth, and I've been told that since I was
No, so
I
they
get
do
really bad
so
mosquito
like
bites.
shampoo and soap or deodorant sprays, they're attracted to that. So be stinky everywhere on your body except for your feet. Wash your feet with just water, though. No soap, just water, and then just be stinky. So when you're camping, don't bathe.
Don't bathe.
That may
My
be a
takeaway,
challenge anyway.
don't bathe.
It can't be.
There was another question by the same subscriber. I'm not going to say their name just because I don't know if they want their name said or not. But I don't know anything about mosquito nets, but they asked also, mosquito nets are so cheap, can we increase their availability for people, or is there another way that we can sort of combat this, hoping not to get bit?
No, mosquito nets, again, as long as there's no holes, because we all know everybody sprays their DEET. Well, I don't, because they don't bite me, and DEET does work. I don't know how good it is to put that on your skin, but that's a separate story. It does work, but the problem is we've all been there when we've missed this tiny spot and they find it, the chink in our armor, every time. And again, they're programmed to do this because of survival. Mosquito nets are one of the things that the Gates Foundation and another aid organization hand out. I mean, tons of them in Africa. If they are used properly, they actually work very well. And they are cheap. So they're sprayed mosquito nets too. So they're sprayed first with chemicals like DEET type chemicals, and then, or DDT even now again. And then they do work if used properly, and they are cheap. So yes, they are being distributed in huge numbers across Africa, specifically again for children, who are 90% of malarial deaths are children under 5, and it's just their immune systems aren't fully developed yet, which is why we get so many childhood diseases, whether it's polio or diphtheria, or I can go on, and thank goodness for vaccines. So yes, mosquito nets do work. Citronella candles not so much, but you can waste your money. You can waste your money if you want.
Fantastic. Don't shower, and citronelle candles are not the answer.
Don't shower.
Okay, that is all the questions that I saw come
Oh,
through in the chat,
excellent.
Dr. Z. So,
Thank you. This has been fascinating. It is quite amazing how you picked up a topic, mosquitoes, and the amount of knowledge that you have conveyed to everyone today, but in general for all the people who read your book. So I thank you for sharing with us the fascinating world of mosquitoes. You know, the next time one lands on me, I'm going to think about how those little bites took a big bite out of society's progress in so many ways, historically for millennia. But as the African proverb, which was quoted by the Dalai Lama, actually says, if you think you are too small to make a difference, try sleeping with a mosquito. So I think that really captures.
I think it's right here.
Oh, you have it there. Oh my gosh, there you go. was that right behind you? I missed
Yeah,
that.
if you think you're too small to make a difference, then you've never, I can't read it, spent a night with a
You
mosquito.
never spent the night with a mosquito. African proverb. Excellent. Yes, exactly.
It's just too small to read
I
back
didn't
here.
see that.
And Yoda was being lazy, so he didn't.
Well, we can talk about Yoda another time. That's our show for today. Next time on Docology, we will hear from Professor Marion Nessel, who will share with us her decades of work on also a most timely topic, which is food additives. But remember, if you are a Docology subscriber, you can join the show. You just have to click on the link in the bio. And so tune in next time, because the topic we cover may just save your life. Docology is a production of Hang Media. Our producer is Catherine Warren. Ronnie Selig is editorial advisor. Our creative director is Anna Richard. Janine Wilson of Wilson Media Group handles paid marketing. Our publicists are Leslie Ann Wade and Jerry Caracoli. Theme music was composed by Nick Kitts. Subscribe and join our community at docology.life. Until next time, move, wash your hands, and stay healthy.